Members of the Canadian team, that's the team that was formed to actually carry out the experiment, was Norm Broten. Norm Broten arrived at the National Research Council in 1959 to undertake solar observations with Art Covington. Became interested in galactic and extragalactic astronomy, and therefore was very susceptible to the idea of a long baseline interferometer. The group was formed in 1965. So it would be a great pleasure to call on Norm to give his contributions, which are reflections and reminiscences, some of them humorous, I might add, of the early days of long baseline interferometry.
I believe this gadget's a little bit too technical for me. I don't think I can put it on. I was coerced into giving this talk, and I have Paul to thank for that, which I intend to do over some time in the future. And I'm unlike Herb, I'm not fettered by factual things. I don't have any notes that are referred to. My house is a complete disorder, and I couldn't find anything in it for what I did have in the first place, so I can talk freely about on things, and if you guys want to correct me, that's up to you, but I don't much care. The Canadian effort in long baseline development in the 65s and 67 required a rather special set of circumstances, I think, in order for it to come off. In my view, these circumstances were that, first of all, had to be a dedicated group of scientists, absolutely fundamental, engineers and technologists, the whole works. It had to be a team, because it was a big effort. Secondly, the director had to have confidence in the research staff and fully support and defend their efforts. Thirdly, that director had to be supported by the president and the council in order to throw the weight of the research council behind this, and it was a big undertaking for any other institution to do. And lastly, or maybe not lastly, but a very important thing is that the political attitude be favorable to basic or curiosity-oriented research that may not have any immediate returns. I believe that all of these conditions, or most of these conditions, are not present in the Research Council this time, or perhaps even in the universities, and that such a research effort could not be mounted at this time. Now, much of what I have to say reinforces what you had to say, Herb. But I'll probably will go over it in my own words. There were a remarkable set of experiments in England at Jodrell Bank in the late 50s and early 60s that was really the kernel for the development of long baseline interferometry. The success that Jodrell had in linked interferometry was astounding, and it showed above all that there were sources out there that were unresolved with resolutions as small as about 2/10 of a second of arc. This was really quite astounding when that happened. Everybody thought it wouldn't be so. There was a second set of experiments about the same time which showed it was possible to use post-detection correlation for interferometry. This was followed up by Carr at the University of Florida, where he did some very remarkable work on particularly on the planet Jupiter. But as Herb has shown, that post-detection methods suffer from signal-to-noise problems when the signals are weak, as one would expect quasars to be. So it really didn't have, the post-detection one didn't have much to do with the development of long baseline interferometry, but still it was in the wings at that time. Now, in 1960, the Department of Energy, Mines and Resources opened the Penticton, Dominion Radioastrophysical Observatory Penticton, and it was principally for studying the distribution of neutral hydrogen. But they had an opening symposium, and at that symposium, there was a suggestion made that the observatory be linked with the Prince Albert radar station in an independent link with tape recorders and separate oscillators. So that's probably the first place this was mentioned in Canada. However, they talked about using 1 megahertz bandwidth and millisecond of timing accuracy, and we all know that at least it has to be, timing accuracy has to be at least 1 over the bandwidth, a little better. And it was very easy to show that this concept was, at the present time, misplaced. And until we developed better methods of getting timing and oscillator frequency stability, it just couldn't be done. When I was returning from Australia in 1965, I took the usual Busman's tour and stopped at all the observatories I could. And when I stopped at Penticton in July of '65, John Galt told me that the concept of long baseline interferometry was being revived. And he mentioned that Herb Gush had been doing some work on it, and Alan Yan, and that he was really quite interested in the project and wondered if NRC would be. He said I couldn't reply for NRC, but I myself would be very interested in such a challenging project. So I reported this to our good director, Dr. McKinley, when I returned, and he was, I suppose what best you could say was that he was, had cautious interest in it. He could probably foresee the expenditures of great amounts of money and manpower in order to bring this off. Now, I don't remember the exact date of this, Jack, but you were over in Dr. McKinley's office in the early fall of '65, and I was asked in, and Dr. McKinley asked me if I would like to go to a meeting in Toronto to talk about long baseline interferometry. I don't remember the date of that meeting, but I think it must have been in September or October. I'm not sure.
September.
September, yes. But before I left for this meeting, he asked me once again if this concept was sound. I said I believed it was, but it was technically a very difficult experiment. At that point, he said, and it was rather astonishing to me, he says, well, you go to that meeting and you assess the proposal, and if you're satisfied that the proposal is sound, you can commit me to $250,000 of the money. That was a lot of money in 1965, and I was astounded at this. When I returned, I told him that we'd committed him to about $125,000, and his reply was a bit laconic and something to the effect that it didn't have to all be spent at one time. To the best of my memory, those present at that meeting were Gush and Yen, Dr. Locke, John Galt. I'm sure Bob Chisholm was there.
No, I don't think so.
He wasn't there.
That was before the Prince Albert meeting.
Okay, then he wasn't there. I didn't remember that. But it transpired that Allen had been in contact with representatives from Ampex who had recently sold some new tape recorders to the CBC and were anxious to palm off their old ones, and we were likely looking suckers. However, they repeatedly had a bandwidth of 4 megahertz, and they also supposedly had the time stability that we required. Furthermore, we had some knowledge that a similar sort of proposal was going ahead in the States, and that they were proposing to use narrowband digital recording, 300 kilohertz, I believe, Ken. And but they had a very big advantage because they were going to use the Arecibo dish, 1,000 foot in diameter. So we needed the wide bandwidth if we were going to be competitive. So I think at that meeting we agreed that we would pursue this idea of buying those tape recorders. And furthermore, we knew we didn't have clocks good enough, and we decided that we needed to have rubidium clocks. So there went each of the tape recorders, 25,000, and also the rubidium clock's about the same. So there's the 125,000 of McKinley's money that we spent in one fell swoop. Not all in one place. Obviously, you have to have some sort of a team effort for this. And the Canadian team has developed a scientific team. John Galt from EM&R. Jack Locke saw the light and joined the National Research Council before that time, or during that time. Tom Legg, Bill McLeish, Roger Richards, Bob Chisholm from Queens, Alan Yen and Herb Gush from University of Toronto. Unfortunately, 2 members of this team have already passed away. Bob Chisholm many years ago, and Bill McLeish just this last few months ago. Well, there was a large amount of equipment to be built, and there wasn't all that much in the way of resources. So a lot of discussion centered about how the heck we were going to do this. And surprisingly enough, an awful lot of time was spent around trying to figure out how we were going to align these tapes. How does one put on time marks good to about 1/10 of a microsecond and identify the correct second, the correct millisecond, the correct video line? Well, we knew how we could put on the pulse, all right. We had some synchronometers around which were used for the time service, and they put out a nice little narrow pulse, which you could see on the video. Well, what other way of putting on, identifying the second by using, one of the most sophisticated of all service systems, the human voice. And those of you who have been fortunate enough to see that glorious film, To the Edge of the Universe, have seen mature scientists counting into a microphone 1, 2, on up to 99 and 100 in perfect synchronism with the clock. Surprisingly, this method worked very well. It was really quite easy. In fact, one of our prominent members, who was noted for his micronaps, was heard to count up to about 10. Then all was silent, except for some gentle breathing. And then, come on, 99, 100, and everything went off. Without a break in his voice, without any indication that he missed anything. We still got fringes from that tape. Well, ARO was supposed to be the master station because, I don't know why, but it was the largest one, I suppose, at that time. And we adopted the method of fringe rotation and phase correction on recording. So we set a synthesizer to about the right frequency, and then as to drift it over past and through the zero frequency, we then punch in some new numbers in the synthesizer. Well, that worked fine for sources near transit, but it sure required some nimble fingers when you were further away from the time of mean transit. Well, the stage was set. The tape recorders arrived. They were, as Vic said, they were sent off to Queen's University, and the whole lab got filled up with equipment. And Bob, I guess, Chisholm, he co-opted just about everybody he could, including those members from Ottawa who were willing to drive down there to help him. And I think the learning curve was pretty long for people not accustomed to TV, and certainly to video recorders the CBC had cast off. And besides, what scientists couldn't improve on something engineers had made for the mass market? So, to explain what that meant, really, you have to realize that the sync pulses are about 11 seconds long, and the line is 64 microseconds long. 11 microseconds long, line is 64 microseconds long. And they were going to drift in and out in phase. So the correlation coefficient would go up and down by about 30%. This, in fact, did prove to be troublesome in the end, but our good scientists thought, well, we'll make it work with 1 microsecond sync pulses. And to their credit, they got one machine to work using 1 microsecond. But 2 or 3 months was spent trying to get the other 2 machines, and they were completely balky and wouldn't work properly. And finally, I think Jack and Locke and I decided that was enough. We've played around long enough of this. We've taken them the way they're designed to be, and we'll start operating. Now, I should mention that there was quite a large technical team also who assisted us. And I'm sure I've left off many from this list. But the principal ones that I could think of in a hurry here were Roy Hamilton and Mike Robinson from Penticton, Emer Ellis, Fletcher Morrison, and Eric Stevens, whom unfortunately couldn't stay. He was here for a moment. From NRC, Frank Dodd from Queens. I think there must have been more from Toronto, but I can only remember George Watson. And I mustn't forget to give credit to the Prince Albert radar station, who did assist us. In fact, we required an oscillator with phase locked to our standard at 32 megahertz. And that was built entirely at the Prince Albert radar station for us. Why 32? Well, you can easily double 2 to and double it, keep on doubling the result, and you get 32 to the power of 5. Incidentally, the 2 is gotten from 1, so does that prove that 1 to the 6th power is 32? Well, in all groups there had to be a leader. So Alan was made the leader, and he was given a hard hat. Unfortunately, he's not here. His hard hat is not here. But I think the reason why he was given a hard hat was that somebody had to stand by these synthesizers and correct the frequency all the time. And to make sure they didn't fall asleep, we had a mallet hanging on the tape recorder near them and to make sure. During almost all this time, we had pretty good contact with NRAO. I remember Ken and I staying in touch for a good length of time. I'm not too sure exactly when it started. He says it was in December of '65. That's possibly true. I don't remember. But I remember in later years that the question would be immediately on the phone ringing and answering us, have you got any fringes yet, or what stage are you at, are you ready to observe yet, and so forth. And we were pretty constant. We just about knew exactly where the other team was in their efforts at all times, particularly in the later stages when we were trying to find fringes and couldn't find them. I think I'll have the first slide now, if I may, just to show you what some of this equipment is like. And you see there are the old cast-off CBC tape recorder and some of the electronics associated with it. The scope was continually plugged into this because that's the nature of the beast. You had to keep on adjusting them. These machines wouldn't operate if the temperature in the room was about 65 degrees Fahrenheit. So even in the middle of the winter, the air conditioner had to be running. There was 2 or 3 of these machines, tens of kilowatts of power being consumed. And after about 10 hours or so on that climb, it got kind of cold, and it was not at all unusual to see a scientist backed up to those big tower tubes you see over there to warm up from the heat generated from them. One time the air conditioner ceased, and it began to get hot in the room, and our trusty technician, Joe Fletcher, opened the windows to cool off the room. Unfortunately, it was about 40 below out. Unfortunately, the radiators were right underneath the window. And when Joe arrived the next afternoon, he found a very distressed and annoyed Mr. Dustin supervising cleaning up of massive amounts of water which had drained out of the broken pipes. I think Joe was persona non grata for about 2 or 3 months at that time. The next slide is just an extension of showing the equipment. You see the mallet hanging there on the edge of one of the chassis just in front of what we used to call the beta or phase control adjuster.
It's on the desk.
It's on.
Beta control is on the
Beta's.
on the table.
Oh, it's on the table, isn't it? Yeah. Yes, sir, it is right there. That's the later one that was driven. We had one which was hand cranked for a while. Well, about this, that's fine for that slide, you know. About this time, NRC was thinking of collating some 7 hours of film on the construction of the telescope. And I was called into Dr. Miller's office and introduced to, I believe it was a Mr. Anderson, who was going to be the director to take this film taken by Grant Crabtree and put it into a film. Well, he was not very happy with the idea of film and construction of a telescope. It had to have some sort of a keynote, something to be built around. So he wanted to go up to Algonquin and film some radio discovery being made. Well, I pointed out that radio observations are pretty boring. You sit there for hours and look at a chart recorder or look at nothing, and then things go ahead, and then afterwards you analyze them. That didn't deter him. In a moment of indiscretion, however, I mentioned that we were planning a long baseline experiment. Wow, that was the stupidest thing I've ever done, I think. Yes, their interest peaked up, and they wanted to film this experiment. I said, well, we wouldn't know the results for months, maybe. Oh, that didn't matter. We'll come back and we'll film you getting them when you're doing the results. I says, well, we wouldn't know that either. Oh, well, then we'll reenact that part of it. But we want to film the actual taking of the experiment. So, like opening night at the opera, we had to contend with lights, cameras, slew of filmmakers, and along with temperamental recorders and so forth. For some strange reason, these cantankerous video machines required about a week of adjustment before they begin to run. And then they would run beautifully for about a week, unless you had a power failure, in which case you replaced massive amounts of 12A7s or other vacuum tubes and spent hours readjusting them again. Well, like any good scientist, Alan always thought he could make them run a little better. And he certainly is not one who takes an instruction such as leave the damn thing alone. And he always thought he'd give it a little tweak and it would work a little better. So we got up the idea, and unfortunately he would have brought it. He isn't here at this time. We gave him a screwdriver which had a smoothly operating ball bearing on the shaft so that he could turn the handle all he wanted to. After that, the tape recorders ran a little better. Also, time wasn't very well known in those days, and we needed to have timing accuracy to 1/10 of a microsecond. So we decided we would ship our clocks around to the various sites. We'd synchronize them, ship them, and then close the circle when they come back and see how the timing accuracy had been, and from that interpolate what time it should have been at the time we were recording. The next slide, please. This one's pretty dark. Better turn. Oh yes, this is not the timing accuracy. This is the. We had in Algonquin we had these filmmakers, and all the tape adjustments and everything else. All they had to do at Penticton was smoke their pipe and occasionally talk into a microphone. The next slide, please, Joe. You see in this one, it's pretty dark, that the guy became known as Bedroom Joe for taking in his clocks always with him into the bedroom and sleeping with him and making sure that they kept running and so forth. He took their clocks around. Thank you. Finally, they're all assembled at NRAO. Video recorders, multipliers, astronomers, engineers, technicians, and we decided that we would ready for a test. This was middle of the winter, I guess, in 67, early 67, and we ran a test with the 10-meter telescope, which is only 200 meters away from the 45-meter telescope, and everything worked like a charm. These were completely independent tape recorders, independent oscillators, so we were elated as a result of this. And the question then was, what do we do? Do we go for the big one, or do we build up gradually? Penticton to Prince Albert to Ottawa, and then or NRAO, and then NRAO to Penticton. Well, of course we went for the big one. So we airshipped everything to DRAO, and time had arrived. We were ready to go. We forgot about the film crew, however. But we needn't have worried too much because the darn clock stopped. And we had to bring back the clock from Penticton. And to save time, they decided that they would, I think it was Roger Richards, now in the end we went down to Toronto to reset these two clocks together. And they commandeered an office manager's office in the airport manager's office in the airport. And he arrived the next morning somewhat angry, I guess, about finding his office filled full of electronic equipment. So the clocks went back again, and then we were ready to go. Everything all set up. Film crew in place this time. Start recording, and they would like to have lights somewhere else. So they'd take their lamps and plug in a kilowatt lamp here, and wham, there went all the power. Replace half a dozen 12A7s in the tape recorders, tweak them up again, get started again, the same thing would happen again. It took 8 hours to make a 1-hour film that night. What a night. However, it was done. Tape was sent back by air to Ottawa, off to Ottawa, pick it up, back to NRAO, open the box. What do we find? Daffodils. These guys out of Penticton with their balmy weather were going to rub it in a little bit, you know, about how warm it was out there, so they sent daffodils back to us. But the tapes were there too, and we played them back, and back, and back. No results. Bring the clocks back, they're 6 seconds out. So, send them back again. Another experiment. And they stopped again. We had trouble keeping those clocks running, so send the clocks back to the airport, and we go down the airport this time. So I think there was 2 or 3 of us. Most of us had been working long hours, too tired to drive, but Bob got a driver to take us down. And since we were tired, I thought, what the heck, we need to rest. I'll rent some rooms. So I rented 2 rooms, one to put the noisy clocks in and one for us to sleep in. I forgot I only had $6. I asked the other guys, they didn't have any more. Nobody had a charge card. It took some talking to get that hotel to accept a private check. Well, on April the 15th or so, 15th, 16th, we had made another tape. Tape come back to Ottawa. Play it back. Absolutely no fringes. Nothing. So there was the question. Had we taken too big a step? Were the sources completely resolved? Well, maybe we had taken too big a step. Maybe we should have been smaller. Maybe we should have gone to Prince Albert. We were thinking all things over. Maybe the experiment that we'd run at NRAO between the 2 dishes worked only because they were so close together, and there was some hidden timing things which didn't show up in that baseline. So the Defense Research Board had a 60-foot dish in Ottawa, and we pressed Dr. McKinley into talking the director there to allow us to use this telescope, this antenna of theirs. And so we rushed the equipment down to DRB. I don't know, the poor guides just about had it fit. Here we are rushing in and out all hours of the day and night. 10 or 12 of us, and we only had 3 passes we shared between us. Are you Dr. Yen? Yes, I'm Dr. Yen. How come your eyes? But that experiment was eminently successful. So then we were pretty certain the technique was all right. Back up to ARO to organize things in it, so forth. One morning after spending about 20 hours or more up, I phoned Ottawa and phoned the office because I think we wanted something up from Ottawa. And it was about 8 o'clock in the morning, and Dr. McKinley was in the office, apparently. And Mrs. Burrell answered the phone, and she says, Dr. McKinley is here. Would you like to speak to him? Well, I was tired in that. Grumpy, and I says, no, not particularly. There was a long, pregnant pause at the other end. Then Lorne Doherty picked up the phone and says, I don't think you understand, Norman. Dr. McKinley is here in this office. Would you like to speak to him? I says, no, not particularly. So a shorter pause this time, and I could hear Lorne talking to Dr. McKinley. He says, no, not particularly. So McKinley picked up the phone then and chuckled. He says, I gather from that you haven't got fringes yet. Things were getting pretty hot for him. And one day, when I was playing tapebacks, I got 5 phone calls from him in one day to see whether or not we had any fringes. He had authorized the expenditure of all this money without going and getting approval for the project ahead of time. And I think the council was sort of stomping on him a little bit. And he was really getting quite anxious for us to get fringes. And in fact, he told us a few times that we should just keep on walking west. Or north. And then he come up to look at us, playing back tapes, and he says, it's sure a heck of a good thing you guys don't have the American system. You couldn't get all your switches thrown in 3 minutes. Well, shortly before the NRC meeting was going to be held here in Ottawa, Alan and I were up playing tapes once more. And just about the last time on the Sunday morning, I was playing this thing, and I thought I'd noticed a jump in the tape recorder on the timing. So I told Alan this, and we tried some different timings that we hadn't tried. And there come out the fringes. And I think the next slide shows what happened, and at that time, it will be very dark, I think, Joe. You see on the floor here miles of tape recorder laid out, and you see John Galt making these fringes so we could show them at the meeting that's going to be held here in Ottawa. I think it was a Monday or a Tuesday. Well, at least that chart that we copied off our chart is here, gentlemen, for you to look at. And I think I'm going to stop about there for now, except I have one more slide I'd like you to show, and it's merely a reminder that you have lost a good telescope. Thank you.
Thank you very much, Norm. What Norm hasn't told you is that they had to reenact this discovery for the film. And I can assure you that they did not get an Academy Award for the performance.
Yes, but we didn't then reenact the play, the actual taking of the film.
Yes, Peter.
What date was that? The actual case film reenactment, and who was the one that could count accurately in the sleep?
What date was what?
When you got the fringes.
When we got the fringes?
I can answer that, Norm. It was May the early morning of May the 21st, 1967. And that date was rather interesting because Alan Yem had submitted a paper to the joint meeting at Berkeley, which was held in Ottawa that same spring.
It's on this chart.
And Alan had submitted that abstract months before, of course, to the program, to that program. And he was to deliver a talk on May the 23rd. Now, this is 2 days after the first fringes had been found. And the significant thing in his abstract is, he says, details of the instruments and observations of some quasi-stellar objects will be discussed. Alan was always optimistic.
I have perhaps one further thing to add to that when we did get these fringes, we knew at that time that Marshal Cohen, who was going to be the first speaker in that morning, was going to announce that they had not got any fringes over such a long baseline, and that apparently there were no unresolved sources in the sky. So we took Marshall aside and says, for God's sakes, don't say that, because Alan had this very same chart here, which he had up on the desk, which shows the fringes that we got to on 183 kilometers, but on this side of it, and this is the chart that was shown on 20 years ago.
Norm, my second part of the question, who was the man that could... I'm interested because that's important. I mean, it's not a man that he can talk in his sleep and still keep it accurately on the time.
Oh, he wasn't asleep when he talked. He just woke up and kept on counting. But he could go to sleep in between seconds.
Well, I thought you said he latched in on the right second.
Oh, sure.
Well,
After a pause.
he must have been counting in his sleep.
That was Alan Yen.
That Alan in here to defend himself.
Yeah, Alan could go to sleep in between seconds, Sean.
Well, I know Alan, that is something I didn't know about.
Say, of course, that we've actually gained in a much better telescope for doing molecular astronomy than this one. But my question to you is, what was it that made you finally find the fringes? What was the key to what was different?
The key that was different was that I noticed that the jump in timing in the tape recorders.
But what, I mean, had you never tried that?
No, I never tried that larger one before.
There was a real...
Quite a large jump, yeah.
Well, the one, I guess I don't understand what you mean by the jump.
I think it was one line that jumped, one whole line that jumped, and we had never tried a whole line. 64 microseconds.
There's a million microseconds per second, by the way. That's a hell of a lot of people. When you look at 5 microseconds at a time.
Okay, so you're only trying much smaller intervals.
Yes, the correlation disappeared with 0.3 of a microsecond. 150 microseconds was half power down on our correlation rates. So, see? And whereas we had, I think we had 4 channels running at that time, you couldn't search very far at any one time.
What was the source, Norm, and by how much did your first success lead the Americans?
No, I'm not going to answer that. We got 2 guys coming up to speak afterwards. Source was 273, but I don't know how much we read. In fact, we led them at all. I don't even know that.
Pick this round this way there.
Yes. I think it was neck and neck.
It's open to debate who was first?
Well, it's neck and neck in a way.
It was a leapfrogging of baseline.
Yeah.
You had a big gap between the observations when you found fringes.
Yes.
We had the fringes, but this isn't where they were.
Further questions? Thank you very much, Norm. The next speaker is Dr. John Grote, who is not here today, but like Dr. Krauss, he has prepared a video of one of the early people in the LBI experiments. At the time, he was the director of the Dominion Radio Astrophysical Observatory. John has titled his talk, Beginnings of Long Baseline Interferometry in Canada, A Perspective from Penticton. We'll have to forego that presentation. But at this time, if there's anyone else who would like to make a comment or relate some amusing or otherwise event that took place in the early days, we could have it now.
I wasn't involved in the early days,
No.
I know that. But you may be interested to know that the tape recorders that replaced the ones that you guys got from the CBC are still being used. Now that they have not been replaced since.
No.
22 years later, they're still in use. And this summer, I understand that we're replacing them, so if you do need some updating.
Thank you very much. But yes, Dr. Mortimer.
May I give you a small thing to go back to Reber's thing? Many years ago, this is botanic. There was a fellow at the farm, the name of Bruce Cummings, who was working on the germination of a Chenopodium species. And he had a lot of data that on the rate of germination that looked something like this over the year from about 95% down to 75%. Every week, it was very good data. He had 2 years of it. And of course, couldn't figure out what the hell to do with it. So I suspect what happened over 1, 2, or maybe 3 years, somebody said maybe it's coming from outer space. And from somewhere, he got some tracings. I don't know where he got them. Of the radio transmission, somewhere around Ottawa, I imagine it's some of you people, for these 2 years that he got. And they're just the recorder charts. He got them scaled down to the same scale that his charts were. And if he precessed the radio noise, I don't know what frequency it came out
Yeah,
at.
that's the radio noise. I was coming across those charts a few months ago, and I was amazed at the correlation if you take out the secular trends.
Yeah, and if you precess the radio by 2 days, match the peaks exactly for 2 years. He had an awful time getting that data published. No explanation for it, but it came to me to review, and I said the correlation is absolute, the experimental data are good, the explanation is for the future, publish it. And it did get published. It's down here somewhere, I didn't have time to, I wanted to dig it out for today, but I haven't tracked it down yet. I used to have a reprint, but I threw it out when I was retiring.
I was also told about the tremendous cost to do that agricultural experiment, $40,000 or so. Am I right in that?
What's that?
The cost in producing the data, the germination rate.
Oh, well, he was working on the flowering of this thing and red light effects on it. Yeah, it was very expensive, I suppose, and one of them, but that's something that
Roger.
I have one rather amusing anecdote. When we went to Toronto to synchronize clocks with Arlington, we nearly shut down the whole airport because not only was the airport manager furious that we'd come to his office, but when the clock was being loaded onto a DC-8, it was put on one of these moving belt loaders, and it was put on very carelessly, and it looked as if it was going to topple off. And so we both sort of jumped up on top of the nearest truck. There was a little truck parked underneath the conveyor to make sure that it didn't fall. And fortunately, the supervisor pulled us back. He said, if you had touched that clock, everybody would have walked out. He said, this airport is completely unionized. You would have shut down the whole damn airport. So we were somewhat chastened when we left. The clock didn't fall. But, and the other thing which was amusing was it was labeled atomic clock. Because the staff were all rather afraid that it was uranium or something.
After that, we called them rubidium clocks. Any further comments?
Just one in relation to that again, Jack. When we did try an experiment to Australia, which would have been the longest baseline ever tried, because the source was below the horizon for both of us. We had to skew the beams off 5 beams in order to get any common time. But we were very careful to have the bill of lading, saying frequency standard almost. Bill was taken over and a pile walked back. Let's see these damn atomic clocks of yours. Didn't fool him on this.
Yes.
I think there's some comment about the total resources needed for this experiment. Can you calibrate me? The resources that went in, how does it compare with the annual budget of an HIA section? What ratio of your section budget would have had to go into this to do it?
That's time for line.
Well, I can't answer that question because I was not section head or director at the time that the experiment was started. But we did make an estimate, I recall, of the cost of all the major pieces of equipment. But we didn't do a thorough study of the cost of the experiment before we submitted the proposal. And I think that was a wise decision.
Exactly, it would be fair to say that aside from the monetary cost, just the support effort involved, the technical support involved over a period of 1 or 2 years was a very significant part of the resources available to the section, and at least partially impacted in a negative way the rest of the ARO operation.
Yes, I think you're right. We realized in the early days that it would be a major effort that no one institution could undertake by itself. And all the idea originated initially between Penticton, that's the Dominion Observatory, and Prince Albert. Very quickly we brought in the National Research Council. Anyone else who wanted to join?
Because when you talk about cost, you don't include the salaries of all the people involved.
No, but that's
as we didn't either, fortunately.
But many of us did some other things during that period, although it seemed that we were devoting all our time to that. that wasn't strictly true. Yes, Frank?
As you look back, how much did the NRAO competition figure in you urging you to get it done quickly? Were you paced more or less internally, or was there the awareness that there was those competitors down south who were working away also?
The international competition was crucial. There was some pressure, internal pressure, but it was not as pressing as the international pressure. And it made us take shortcuts, which some of the engineers were loath to do, which the astronomers pressed for. One of them was to push the buttons on the synthesizer by hand rather than wait for a proper phase shifter. And to make the observations at transit rather than much more difficult time, far off in radius. Those sort of decisions we made just to cut time with the knowledge that we would have to clean things up later if the experiment worked. So we used sort of this string and sealing wax approach, which is often a good one, I think.
Second part of the question is, I think it was mentioned that there were contacts between the NRAO group and the Canadian group. What was the quality of those contacts? You know, showing everybody what you had and how you were doing it, or just how is that experiment coming? How explicit were the discussions?
Well, as I recall, we knew pretty precisely what.
There was pretty open transmission of information,
yes, I think
even
so.
in the midst of the competition.
Yes, and there was constant communication to keep up to date, to learn whether fringes had been found before we found out. And if it hadn't been for the meeting in Ottawa, I think that we would have simply notified the Americans, and they would have notified us. But the international competition was a crucial part. Would you agree, Mark?
Oh yes, I would agree. It was really friendly cooperation. And I think
It was a good-natured competition.
good nature.
Yeah.
We both knew rather explicitly what approach the other team were having right from the very early days. And essentially what stage they were developing these things too, as we went along.
I think the approaches were different enough, and our commitment to our different approaches was secure enough that there was no danger of it by exchanging information. It helped the other guy, because we were just going different routes. So I think the information was exchanged completely.
I don't think anyone should underrate competition as an exception to progress in science. Well, if there are no further comments, assume the arrangements for coffee are the same as supposed.
Yes, there's coffee outside, and there's some cookies. We're just home baked.